So ask your friends to join fast and everybody write your roll number followed by present in the chat box. Okay, so we are going to start. So all of you, those who haven't joined till now, join fast. Ask them to join fast and mark your roll number followed by present in the chat box. Okay, so we are going to start. So, hopefully this is visible to you. Okay, is it visible? I think if visible, say yes. At least confirm it. Am I
Yes, sir.
audible? Say yes, no, something.
Yes, sir,
Sir, it's
visible.
visible, sir.
Are you listening to me?
हाँ जी सर, आवाज आ रही सर आपकी।
Hmm?
आवाज आ रही है सर आपकी, दिखाई भी दे रहा
Are you listening to me? Say yes, no, something.
Yes, sir, visible.
अरे मेरी बात सुन रहे हो?
Yes, sir.
हाँ जी सर, आ रही है आवाज आपकी।
Am I audible?
यस सर।
Yes, sir. You are
Yes,
audible.
sir.
Write yes in the chat box if I am audible. Okay, okay, okay. See. Okay, so we are here at this juncture basically. So we started discussing about last time this coordinate measuring machine. So just have the brief review what we did last time. So, so we have seen about this coordinate measuring machine that plays an important role in the this, for example, metrology as well as in the manufacturing, particularly mass production, that is the FMS system and the computer integrated system, basically manufacturing. And this is the different kind of say manufacturing. This CMM that we have seen. Basic purpose is to locate the point where we want to carry out the inspection, where we want to carry out the measurement, and it is the machine is nowadays it is a computerized one, that is a computer operated or control, you can say, just like a CNC machine. So there are different versions for this machine. This is the basic structure for this machine, which makes use of say computer. and these are the different types of machines over here. Okay, then we have seen about its features and what the machine stands for. Okay, these are different types. Then this is the probe that we're using. So maybe again it is just like a probe, like a dial indicator probe. This is a variant for this particular probe. These are different kinds of probe and operations. These are user friendly basically. And so these are the, for example, different aspect as far as this CMM is concerned. Application that we have seen, it's, CMM is a sophisticated equipment which offer tremendous versatility and flexibility in the modern manufacturing application. It uses fundamental principle of metrology to an extent that it is not matched by any other measurement instrument. However, its use is limited to situation where the production done in a small batches, but products are high value. It is essentially it is especially useful for the component of varied features and the complex geometry. So these are the features for this particular one. And this in which situation we are going to use, for example, this CMM. These are the situation over here. Okay. Next thing is the optical and the measurement and the interferometry. So today it is an accepted fact that a light wave provides the best standard of for length. The significance of light waves as length standard was first explored by this Albert A. Michelson बोल दीजिए उसको जो भी पढ़ना है W.L. Worley. Although indirectly they were using an interferometer to measure the path difference of light that was passed through a tremendous distance in the space. In their experiment, they measured the wavelength of light in terms of a meter. The known interference makes it possible to accurately compare the surface geometry with the master with the master as in the case of optical flat. So we are comparing the flat surface. Suppose you want to calibrate the surface of this optical say, slip gauge. So for that purpose, we are using this kind of say, system, interferometer, concept of interference for the purpose of calibrating that this particular slip gauges. And for that purpose, we are using even for the optical flat. We are using the optical flat. Optical flat is nothing but a piece of a glass, basically quartz, basically, and transparent, and through which we can pass the light. The microscopic magnification enables the micron level resolution for carrying out the inspection or the calibration of a master and its gauges. Laser are also increasingly being used in the interferometers for this precision measurement. Nowadays we are increasingly using the laser, that particularly this laser holography for the purpose of measurement or to generate the profile, to get the profile. So optical measurement technique, optical magnification is one of the most widely used technique in the metrology. However, optics has in three other principal application and in alignment, in interferometry, and as an absolute standard of length. So look at this is the use of this particular, for example, optical instrument for the purpose of say in alignment, in interferometry, in absolute standard of length. So to measure the standard, that means the length in the alignment. If you want to find out whether the two surfaces, the two, for example, elements are aligned or not, or in case of say interferometry to check, for example, flatness, straightness, etc., or surface, for example, this texture, you can make use of this kind of say concept of interferometry over here. That is the optical instrument. An optical measurement technique to check the alignment employs light rays to establish reference as a line, references such as lines and planes. So we are using light ray as a reference, as a line, as for example planes. Okay, it may particularly you can have the light ray as a reference point to measure the, for example, corresponding straightness, flatness, etc. Interferometry uses the phenomena of light to facilitate measurement at the micrometer level. जैसे surface roughness आपको measure करना, you can make use of this particular thing. या flatness, straightness आपको अगर measure करने वो भी कर सकते हैं. But at the microscopic level, another significant application of this optics is the use of light as an absolute standard. जैसे मैंने आपको बताया था पहले भी हमने देखा है इसमें, because we are using the light. So look at the principle of this microscope. ये तो सबको पता है how the microscope work. The microscope couples two stage of magnification, because why we are using microscope, because we require, for example, this magnification. So microscope couples two stage of magnification. The objective lens from an image of a workpiece at this particular say L1 या I1 कह लीजिए उसको, ठीक है, at the stop and the stop frame in the image so that it can be enlarged by eyepiece. So look at, you have, for example, this is the first one, the view through the eyepiece and enlarged virtual image I2. ये आपके पास होगा इस particular case में. I2 is obtained. Magnification at each stage multiplies, thus highly effective magnification can be achieved with only moderate magnification at each stage. So look at this particular one. So we are magnifying the things, and this is, for example, initially you have the things, okay, at this workpiece is over here. Then you have, for example, objective lens. Then you have, for example, another one, and you are getting some objective, say, large magnification at this particular location over here. Okay. So this is the conception of say microscope basically. So tool maker's microscope. So here in the metrology we are using the tool maker's microscope to check the, for example, wear and tear of your this cutting tool, or if you want to check the surface, if you want to check the, for example, say the tapering particularly in any instrument or any your component, you can make use of this tool maker's microscope. So tool maker's microscope is a multifunctional device that is primarily used for the measurement on the factory shop floor, designed with the measurement of workpiece contour and inspection of surface features. The tool maker's microscope support a wide range of say applications from shop floor inspection and measurement of tools and machine part to the precision measurement of test tools in measuring room. So you can make use of this microscope at the shop floor level, also at the level of say, for example, metrology. That means the you can say the lab basically, or for the precision measurement. The main use of tool maker microscope is to measure the shape, size, angle, position of a small component that falls under the microscope measuring range. So what we are going to measure, that the shape, size, angle, position of small component component that falls under the microscope's measuring range basically. So look at here the feature for this microscope, tool maker's microscope. Okay. So it consists of say column, and then you have, for example, this is the eyepiece over here. This is the focusing knob. This is the entire, for example, this optical system over here. That is lenses and all that thing. This is the clamping screw, then surface illuminator. So here you can have, for example, some light, sort of a light source, so that that can be focused on the work part that is to be measured over here. The micrometer. So you have the two kind of micrometer to control the x and y direction. Z के लिए ये तो आपका है मान लो, just like a coordinate measuring machines. Okay. So at this level also you have micrometer. At this level you have the micrometer that is called a transfer for the transverse movement, is for the longitudinal movement, and this is the focusing knob. So we can focus on that particular place. This is the eyepiece. This is, for example, base where it is mounted. So usually it is mounted on the flat surface. You can just consider on the surface plate basically for the purpose of avoiding any deviation in terms of the flatness and the straightness. So this is the another version of this tool maker's microscope, optical head. जैसे मैंने बताया था आपको, this is optical head. This is a cross slide. Okay, so that moves in this direction. ये आपका micrometer है, ये table है, ये इस direction move करेगा, and so on. तो ये सारी चीजें इसमें होती है. This is the actual figure of this tool maker's microscope. This may be available in your lab basically. Maybe I don't know exactly, but शायद है हमारे पास. Application of tool maker's microscope, it is used in the shops or inspection of a screw thread. जैसे मैंने बताया आपको screw thread में अगर आपको profile देखनी है, you can make use of this kind of a microscope. Gear का आपको teeth का profile देखना है या measure करना है मान लो, वो भी आप कर सकते हैं. And the other small machine part. Its application include the precision measurement of this tool test tool in the tool room. It helps in determining or to determine, for example, the diameter of small hole which cannot be measured with the micrometer and the calipers. To facilitate template matching inspection, small screw thread and involved gear teeth can be inspected using the optional template रेक्टिकल्स. तो वहाँ टेम्पलेट रेक्टिकल्स होती है इस तरह से, तो वहाँ आप उसको मेजर कर सकते हो लाइक दिस पर्टिकुलर. It enables inspection of a taper on the small component up to 6, for example, say second बोला हुआ है इसमें, ठीक है ना, 6 single dash है. Sorry, single double minutes होगा. Okay. So optical square. Now another instrument that we are going to use over here that is called as an optical square. And optical square is useful in turning the line of this side by side में light होगा ये, ठीक है ना, by 90 degree from its original path. Many optical instruments, especially microscope, have this requirement. An optical square is essentially a pentagonal prism. क्या होता है? Pentagonal prism. Pentaprism बोलते हैं उसको. Regardless of the angle at which the incident beam strikes the face of the prism, it is turned through 90 degree by internal reflection. This is important aspect over here. Unlike a flat mirror, the accuracy of pentaprism is not affected by the error present in the mounting arrangement. So look at this particular एक prism है इसमें इस तरह से, जैसे मान लो अपनी मिरर यूज किया, इसको 90 डिग्री टर्न करना है, so there are chances of error at the base, there are chances of error at this particular location, and whereby we are not going to get, for example, exactly 90 degree turning of this particular light. So look at reflected ray without error, reflected ray due to mounting error, reflected ray due to the base error. So these are the possibilities. These possibilities that can be avoided by using, for example, say optical, this particular square. It's a pentaprism. So the light everywhere at any location, at any direction, or there is, for example, there is a mounting error, there is a base error. Whatever the error, the light strikes at this location, and then it is striking at somewhere here, and then this path is always, for example, say 90 degrees. So you can convert or reflect the light by 90 degree. From above figure, it is observed that the mirror is kept at an angle of say 45 degree with respect to the incident ray of light, so that the reflected ray will be at an angle of say 90 with respect to the incident ray. It is observed that any error in the mounting of the mirror or in maintaining its base parallel in a fixed reference to the beam is greatly magnified by the optical lever effect. These two error in combination may even be greater than the workpiece squareness error. This problem may be overcome by using the optical square. Figure illustrated the optical path through which an optical square जैसे मैंने बताया आपको, ये दिखाया था आपको 90 डिग्री होता है. The incident ray is reflected internally from two faces and emerges from the square at exactly 90 to the incident ray. This is remarkable property, and slight deviation or misalignment of the prism does not affect the light angle movement of the right angle movement of this particular light light ray. Okay. So every time we are getting, for example, exactly 90 degree. तो ये इसका यूज होता है. फॉर एग्जांपल से प्लेन रिफ्लेक्टर ऑप्टिकल स्क्वायर है, तो यहाँ आपको इसकी जो भी आपको मेजर करना है, जो भी करना है, फॉर एग्जांपल, ठीक है ना, आप कर सकते हो. तो यूज ऑफ दिस ऑप्टिकल स्क्वायर टू टेस्ट स्क्वायरनेस. तो ये किस लिए हम यूज करेंगे? जैसे मान लो एक पार्ट है आपका ये वाला, इसका स्क्वायरनेस का मतलब होता है ये जो 90 डिग्री एंगल होना चाहिए, जैसे आपका ट्राई स्क्वायर होता है, उसको वेदर इट इज एक्जैक्टली 90 डिग्री और नॉट, इसको अगर मेजर करना तो यू कैन मेक यूज ऑफ दिस ऑप्टिकल स्क्वायर. तो यहाँ कहीं रखेंगे, अगर ये आपका लाइट रेज आपको मिलता है, फॉर एग्जांपल दैट पर्टिकुलर केस, यू कैन से दैट इट इज यू कैन हैव फॉर एग्जांपल एक्जैक्टली 90 डिग्री. ठीक है. So for that purpose, we are making use of this optical square. The figure above illustrates the use of optical square to test the squareness of machine slide, squareness of vertical slide with respect to a horizontal slide way or bed is the utmost importance in the machine tool. जैसे machine tool में square में बड़ी important होती है. So the test setup requires an autocollimator, plane reflector, and the optical square. It is necessary to take only two readings, one with the reflector at position A and second at the position B. तो ये रिफ्लेक्टर होगा आपका, ठीक है ना. यहाँ लेनी है रीडिंग आपको, यहाँ रीडिंग लेनी है और यहाँ लेनी है, बस दो ही चाहिए आपको, और सबको पता चल जाएगा. A and B, the optical square being set down at intersection of two surfaces when reading at B is kept, reading at B is taken. The difference between the two readings is the squareness error. दोनों रीडिंग में जो आपका डिफरेंस होगा, that is the squareness error basically. उसके बाद होता है ऑप्टिकल इंटरफेरेंस. ये फिनोमेना होता है basically. So look at, you have the light rays, two light rays, and these light rays are having, for example, the same kind of, say, this particular, these are in the phase basically. Okay, there is no phase difference. So naturally, it will look like just like a sine wave as shown in the figure. So one of the light rays, for example A, another one is from example B, and that moves in this particular way. So look at, suppose the two rays have the amplitude y and yb, then resultant wave will have amplitude of say yr, that is equal to ya plus yb. Thus, when two rays are in a phase, the resultant amplitude is maximum and the intensity of light is also maximum. So this is also maximum. So ये आपका ये मिल रहा है आपको yr, समेशन होगा दोनों का. However, if the two rays are out of phase, say by an amount, for example, say del, then resultant wave will have an amplitude that is say yr. So यहाँ जो yr मिलेगा आपको, for example, that is nothing but ya plus yb multiplied by cos del by 2. It is clear that the combination of these two waves no longer produces maximum illumination. तो ये condition इसकी है. The two waves of different amplitude out of phase by 180 डिग्री, मतलब एक यहाँ से निकल रहा है, एक यहाँ से निकल रहा है, राइट. सो उसका वो सोर्स अलग अलग है, ये स्टार्टिंग पॉइंट अलग अलग है. Consider the case where the phase difference between the two waves is 180 degree. The amplitude of resulting wave, which is as shown in the figure above, ये जो दिया हुआ है जैसे, ठीक है ना, this particular one, and this is nothing but the well, as shown in the figure above, is the algebraic sum of y and yb. The corollary that if y and yb are equal, then yr will be 0 because cos 180 by 2 that is equal to 0. ठीक है ना? अगर ये दोनों इक्वल है मान लो तो ये 0 हो जाएगा. This means that the complete interference between the two waves having the same wavelength and amplitude produces darkness. ये important है इसमें. So look at this one. This means that the complete interference between the two waves having the same wavelength and amplitude produces the darkness. This property of interference of light can be used for the linear measurement. ये हम लोग linear measurement के लिए property use कर सकते हैं. So look at here the conception over here. Now ये आपके पास एक light ray यहाँ से आ रहा है, एक यहाँ से आ रहा है, ठीक है ना? दोनों का ये distance same है. So let us consider the two monochromatic light rays from 2 point A and D. एक मोनोक्रोमैटिक लाइट सोर्स है सिंगल वेवलेंथ जिसकी होती है ये ए है ये बी है फॉर एग्जांपल व्हिच हैव द सेम ओरिजिन ठीक है ना ओरिजिन उसका ओरिजिन मान लो सेम है एक ही पॉइंट पे मान लो मतलब ऐसे डिफरेंस नहीं है ठीक है ना वो इसी एक ही लाइन से फॉर एग्जांपल है so the light rays are made to fall on a flat screen that is placed perpendicular to the axis O1 तो ये हो गया आपका O और ये 1 ठीक है the axis O1 is in turn perpendicular to the line joining the two source of point A and B. तो ये जो यहाँ जो ये है, this is 90 degree, is it? Okay. अब होगा क्या? Since both the rays originate from the same light, since both the rays originate from the same light source, they are of the same wavelength. Let us also assume that the distance OA and OB are equal. तो ये distance जो है, ये distance OA भी ये भी same है, ठीक है? Now consider the convergence of two rays at a point 1 O1. तो ये आके fall कहाँ होंगे? यहाँ fall हो रहे हैं, दोनों आके ऐसे यहाँ से ये आया, यहाँ से ये आया, ठीक है? यहाँ मिल रहा है, ठीक है? At O1. On the other hand, at point O2, the distance BO2 is longer than the distance AO2. अब मान लो यही चेंज हो जाता है, यहाँ से मान लो यहाँ चला जाएगा तो ये डिस्टेंस ज्यादा होगा, ये कम हो जाएगा, ये वाला डिस्टेंस कम हो जाएगा, ठीक है? So look at this particular one. On the other hand, at point O2, the distance BO2 is longer than the AO2. Therefore, by the time the two rays arrive at point O2, they are out of phase. तो जैसे मान लो यहाँ आएगा, thereby by the time two rays arrive at point 2, they are out of phase. मतलब ये out of phase हो जाएंगे. Assuming that the phase difference is, for example, this particular one. मतलब इनका मान लो phase difference, for example, ये है del that is equal to lambda by 2, where lambda is nothing but the wavelength of light. The complete interference occurs forming a dark spot. तो उसके बाद क्या होगा? यहाँ इंटरफेरेंस ऑफ लाइट होगा और यहाँ मान लो आपको डार्क स्पॉट मिलेगा तो यहाँ क्या मिल रहा है आपको ब्राइट स्पॉट क्योंकि एक ही जगह पे दोनों फॉल हो रहा है यहाँ क्या हो रहा है कि देयर इज फॉर एग्जांपल दैट क्रिएट अ फेज डिफरेंस और वहां जो आपका मैंने अभी हमने देखा था फ्रॉम दिस पॉइंट ऑफ व्यू जैसे ये देखा था हमने यहाँ मान लो दोनों y भी इक्वल है तो उस पर्टिकुलर केस में क्या होगा और ये एंगल फेज डिफरेंस का एंगल जो है आपका 180 है तो ये कितना होता है द cos 180 by 2 कितना होता है दैट इज फॉर एग्जांपल से ये 0 हो जाएगा तो यहाँ जो क्या मिलेगा आपको यू विल गेट फॉर एग्जांपल डार्कनेस तो लुक एट अनदर केस ओवर हियर उसके बाद क्या होगा एट point O3 on the screen the distance BO3 is longer than the AO3 अब यहाँ आते दोबारा से अब ये लॉन्गर है ये छोटा है ठीक है ना ये BO3 है ये AO3 है ठीक है अब इसमें दोबारा क्या हो रहा है if the difference between the two distances that is BO3 and AO3 is equal to an even number of half wavelengths ठीक है ना मतलब even number of half wavelength अगर मान लो इस तरह से कंडीशन आती है the two light rays arriving at O3 will be in a phase leading to the formation of a bright spot तो अल्टरनेट स्पॉट जनरेट हो रहे हैं पहले ब्राइट होगा फिर उसके बाद डार्क होगा फिर मान लो फिर दोबारा फॉर एग्जांपल से ब्राइट होगा डार्क होगा एंड सो ऑन सो व्हाई बिकॉज़ दिस डिफरेंस से BO3 AO3 that is for example equal to the इवन नंबर ऑफ हाफ वेवलेंथ, ऑड होगा तो डार्क बनेगा, इवन होगा तो फॉर एग्जांपल से दैट इज ब्राइट वन. The process repeated on either side of say O1, मतलब ये प्रोसेस दोनों तरफ से होगी. So you will on the that particular for example surface you will get the dark and the bright spot, and that these spots are called as the fringes basically. So on the screen resulting in the formation of an alternate dark and bright area. The pattern of alternate bright and dark area is the popularly known as, for example, fringes. The dark areas will occur whenever the path difference of A and B amount to an odd number of half wavelength, and a bright area will occur when the path difference amount to an even number of half wavelength. तो यहाँ odd number मिलेगा, वहाँ for example से you have the dark one, bright होगा, जहाँ even है. The number of fringes that appear in a given length on the screen is measure of the difference, measure of the distance between the two-point light source and form the basis for linear measurement. This phenomenon is applied for carrying out the precise measurement of very small linear dimensions, and the measurement technique is popularly known as, for example, say interferometry. इस technique को बोलते हैं interferometry. This technique is used in a variety of metrological applications such as inspection of machine part or straightness, parallelism, flatness, and measurement of very small diameters and among others. Okay. Calibration and reference rates slip gauges are verified by the interferometry. So जो calibration आपको करना है slip gauges का, ये reference rate जो भी होगा आपका, we can carry out with the help of this interferometry concept over here. The instrument used for making the measurement using interferometry technique is called as a interferometer. The most preferred light source is a tungsten lamp. कौन सा लैम्प यूज करेंगे यहाँ? Tungsten lamp with a filter that transmit the monochromatic light source. Other commonly used light sources are mercury 198, cadmium, krypton 86, thallium, sodium, helium, neon, and the gas laser. So यहाँ we are using, for example, lasers also in this particular case to create a monochromatic light source for the purpose of say interferometry. Among all these isotopes of mercury, mercury 198 is the one of the best light source producing the ray of a sharply defined wavelength. In fact, the wavelength of mercury 198 is the international secondary standard of length. ये secondary standard primary तो हमारा हमने देखा था पहले. Wavelength of krypton 86 होता है basically. ऑप्टिकल फ्लैट, तो इसी के बेसिस पे जो हम इंस्ट्रूमेंट या जो कंसेप्शन यूज कर रहे हैं, तो वन ऑफ द मेथड व्हिच इज यूज्ड इन द फॉर एग्जांपल मेट्रोलॉजी फॉर द पर्पस ऑफ आइडेंटिफाइंग और मेजरिंग और कैलिब्रेटिंग द सरफेस और द कैरिंग आउट द लिनियर मेजरमेंट, दैट इज कॉल्ड एज ए ऑप्टिकल फ्लैट. That is called as an optical flat. Okay. The most common interference effects are associated with the transparent film or the wedges bounded on at least one side by transparent surface. Soap bubbles, ये इसके examples है. Soap bubbles, oil films on water, optical flat falls in this category. तो one of ये interference आपको कहाँ से मिलेगा? The concept that is utilized in case of this optical flat. Optical flat is a disc of high quality glass or the cord. The surface of the disc is ground and lapped to a high degree of flatness. तो ये जो surface होता है इसका दोनों ट्रांसपेरेंट होता है, बेसिकली ग्लास होता है, मान के चलो सर्कुलर, दोनों तरफ से ट्रांसफर मतलब ये ट्रांसपेरेंट होता है, दोनों तरफ से ग्राउंड और लैप्ड होता है, एंड इसकी जो फ्लैटनेस है मतलब जो वेरिएशन विद रिस्पेक्ट टू द सरफेस रेफरेंस सरफेस वो बहुत कम होता है. The size of the optical flat varies from 25 mm to 300 mm in diameter, with a thickness ranging from 25 to 50 mm. When an optical flat laid over a flat reflecting surface, it orients at small angle theta due to the presence of air cushion between the two surfaces. जैसे optical flat रखोगे आप, तो जैसे हम इस पे रखते हैं ना, तो there is a air gap basically. Air gap that will create a small angle. ये कैसे दिखता है, and that result into for example say this interference. So look at this is a surface, this is the for example angle which is created by this particular optical flat, and look at this for example say the how the light that pass through that particular say optical flat, and that result into the formation of these kind of say interference of light, and which result into a bright and dark spot. So ये आपका bright हो गया, dark हो गया, bright, dark, sorry, dark, bright and so on. तो इस तरह से पैटर्न बनेगा, ठीक है. तो लुक एट, ये ऑप्टिकल यहाँ से लाइट आ रहा है तो यहाँ स्ट्राइक करेगा, फिर यहाँ से यहाँ जाएगा, फिर यहाँ से आपके आंखों में आएगा, यहाँ से यहाँ. तो यहाँ ये डिफरेंस, ये भी ये जो डिस्टेंस है, बिकॉज ऑफ दिस पर्टिकुलर गैप वो वेरी कर रहा है. अकॉर्डिंगली इट रिजल्ट इनटू द इंटरफेरेंस ऑफ दिस पर्टिकुलर लाइट ओवर हियर. So this look at, this is optical flat as shown in the figure. ये जैसे ग्लास का है, ट्रांसपेरेंट है, इसकी सर्टेन थिकनेस होती है, जैसे वहां दिया है मेरे ख्याल से. ये पैटर्न बनता है, जैसे आप देखोगे ना इसमें, लुक एट, दिस इज एक्चुअल पैटर्न. जैसे डार्क का मतलब है डार्क सरफेस एक तरह से, ठीक है ना. ये मान लो ब्राइट है, ये डार्क है, ये ब्राइट है, एंड सो ऑन. ये इसके variations है. As discussed earlier, when the light from a monochromatic light source is made to fall on an optical flat which is oriented at a small angle with respect to a flat reflecting surface, the band of alternating light and dark patches is seen by eyes. In case of perfectly flat surface, the fringe pattern is a regular pattern and uniformly spaced. अगर अब ये मान लो, ये अगर फ्लैट सरफेस है तो ये पैटर्न जो होगा आपका यूनिफॉर्म होगा, और जहां फ्लैटनेस नहीं है वहां नॉन यूनिफॉर्म होगा. एनी डेविएशन फ्रॉम दिस पैटर्न इज मेजर ऑफ एन एरर इन द फ्लैटनेस ऑफ ए सरफेस बीइंग मेजर्ड. Fringe pattern provide interesting insight into the surface being inspected. They reveal surface condition like contour lines on that particular map. तो ये देखो इसमें क्या क्या होता है. So अलग अलग चीजें इसमें. Look at this particular, ठीक है ना. ये मान लो, this indicate that the surface is exactly flat. अगर इस तरह से लाइन बन रही है तो ये that means there is a, for example say certain variation, concave होगा, convex होगा, like this particular, ठीक है. Look at, this is a contouring somewhere, and look at, this is at 2 point, this is for example say is in contact. So what are the condition? So A कैसे बनेगा आपका? Look at, block is nearly flat along its length. तो ये बनेगा आपका, ये फ्लैटनेस के लिए सारी एक जैसी लाइन होगी. दूसरे केस में क्या होगा? The fringe curve toward the line of contact showing the surface is convex and high in the center. ये convex होगा. This indicate for example convex, ठीक है. Then C का मतलब है surface is convex and low in the center. ये पैटर्न बनता है, मतलब अगर फ्लैट है तो ऐसे बनेगा, convex, concave. Then you have for example surface flat at one end and become increasingly convex. एक जगह फ्लैट है, एक जगह फ्लैट है, जैसे ये फ्लैट है, और यहाँ ये कॉन्वेक्स हो रहा है, ठीक है. यहाँ उल्टा होगा इसके पर्टिकुलर केस में. सरफेस इज प्रोग्रेसिवली लोअर टुवर्ड द बॉटम टू लेफ्ट कॉर्नर. तो सरफेस इज प्रोग्रेसिवली लोअर टुवर्ड द बॉटम लेफ्ट कॉर्नर. तो एक कॉर्नर पे वो फ्लैटनेस भी कम होती जा रही है, ठीक है ना. यहाँ फ्लैट, उसके बाद ये एक तरह से कॉन्वेक्स कह लीजिए उसको, लेकिन ये कॉर्नर पे, सेंटर पे नहीं है, ऐसे कॉन्वेक्स पे. और there are 2 point of contact which are higher compared to other areas of block. यहाँ 2 point of contact है which is higher to other area of block. यहाँ contact में आ रहा है for example. So these are the pattern which are formed. So look at the comparative measurement of height of a slip gauges with optical flat. तो ये जैसे मान लो, look at this particular one, ठीक है ना, A और B. ये सरफेस फ्लैट है, ये ऑप्टिकल फ्लैट है, ये आपकी वन ऑफ द फॉर एग्जांपल रेफरेंस कह लीजिए उसको, दैट इज कॉल्ड एज मास्टरपीस या स्लिप गेज है, ये जिसका मेजर करना वो है. एंड दिस इज द पैटर्न व्हिच इज ऑब्जर्व्ड ओवर हियर, ठीक है. अगर मान लो ये एंगल मान लो आपका थीटा और ये एंगल आपका थीटा डैश है फॉर एग्जांपल. अगर एग्जैक्टली फ्लैट है तो ये पैटर्न बनेगा, दोनों में इक्वल होगा, ठीक है. अगर मान लो तो थीटा डैश इज ग्रेटर देन लेस देन फॉर एग्जांपल थीटा, तो इस तरह से पैटर्न बनेगा इसमें, ठीक है. और थीटा डैश इज ग्रेटर देन फॉर एग्जांपल दिस थीटा, इस तरह से पैटर्न बनेगा. तो ये फॉर एग्जांपल आपका ये रेफरेंस है इसमें, इस पर्टिकुलर केस में. तो ये लुक एट दिस वन. तो यहाँ मान लो 1 2 3 4 है, तो यहाँ ज्यादा बनेगी, यहाँ मान लो कम है फॉर एग्जाम्पल, तो यहाँ इस पर्टिकुलर केस में आपका क्या होगा, यू हैव फॉर एग्जाम्पल से मोर नंबर ऑफ दिस पर्टिकुलर लाइंस ओवर हियर। इन जनरल यहाँ अगर मेजर करोगे आप तो 1 2 3 4 5 6, 1 2 3 4 5 6 दोनों में इक्वल है, इसका मतलब है एंगल सेम है, दैट मींस इट इज परफेक्टली फ्लैट। इस तरह से मान लो तो देयर इज अ डिफरेंस इन द फॉर एग्जांपल दिस पर्टिकुलर एंगल एंड इट शोज दैट द सरफेस इज नॉट फ्लैट। The fringes seen on both the gauges are parallel and same number in same number if the both surfaces are perfectly flat. Otherwise, the number of fringes formed on the two gauges differ based on the relationship between the angle theta and theta dash. Now, let the number of fringes on the reference block Bn, जिसका reference लेना आपको Bn, or a width of say 1 mm. If the distance between the two line between the two slip gauges is L, and lambda is the wavelength of the monochromatic light source, then the difference in the height h is given by the following relationship over here. तो यहाँ देखो आप क्या क्या है, ये आपका L है, डिफरेंस जहां आपने पुट अप किया है, ये आपका फॉर एग्जांपल से L n इंडिकेट फॉर एग्जांपल से नंबर ऑफ फ्रिंजेस n और विड्थ ऑफ फॉर एग्जांपल से 1 mm लिया आपने, ठीक है। एल मैंने बता दिया आपको डिफरेंस है उसका, और ये आपका फॉर एग्जांपल से दैट इज द वेवलेंथ ऑफ दिस पर्टिकुलर लाइट। तो अगर इसमें अगर रेफरेंस हाइट आपको निकालनी, यू कैन कैरी आउट, सो दिस इज द हाउ वी आर मेजरिंग द लीनियर डिस्टेंस ऑफ द मेजरमेंट। सो एल इज नथिंग बट अ लैम्डा एल एन बाय दिस 2 टाइम्स ऑफ दिस पर्टिकुलर एल। तो ये मिलेगा क्योंकि एंगल बहुत छोटा है, तो वो कॉस एक्चुअली कॉस क्या कहते हैं उसको थीटा होता है, बट वो एंगल छोटा है, तो यू कैन सिंपली राइट द लैम्डा बाय 2। The simple procedure can be employed to measure the very small height difference in the range of say 0.01 to 1 mm. However, the accuracy of this method depends on the accuracy of the surface plate and condition of the surfaces of the specimen on which the optical flat is resting. तो ये एक ऑप्टिकल फ्लैट का कंसेप्शन है, इस तरह से अपने पुट अप किया है। उसके बाद आते हैं इंटरफेरोमीटर्स, तो which are based on the same conception. Interferometers are the optical instrument that are used for very small linear measurement. They are used for verifying the accuracy of slip gauges and measuring flatness error. Though an interferometer works on the same basic principle that of the optical flat, it is provided with the arrangement in order to control the lay and orientation of fringes. तो ये आप उसमें कर सकते हो, ये तो मैनुअल हम कर सकते हैं ऑप्टिकल फ्लैट से, बट उसको अगर आपको और प्रिसाइज है मेजरमेंट आपको चाहिए, तो उसके लिए यू रिक्वायर द स्पेसिफिक थिंग दैट इज कॉल्ड एज इंटरफेरोमीटर, जिसमें कि हम ऑप्टिकल फ्लैट यूज करते हैं। इट इज आल्सो प्रोवाइडेड विद द व्यूइंग और रिकॉर्डिंग सिस्टम, तो इसमें आपको व्यू और रिकॉर्ड भी कर सकते हो इसमें, व्हिच एलिमिनेट द मेजरमेंट एरर, तो टू इन ऑर्डर टू अवॉइड द मेजरमेंट एरर। सो इसमें अलग अलग तरह के होते हैं। एनपीएल एक आपके पास यहाँ जैसे दिल्ली में भी है एनपीएल, पूसा रोड में कहीं मिल जाएगा आपको, वहाँ है इसका ऑफिस, तो वहाँ यही चीज करते हैं लोग। तो ये कुछ रेफरेंस है दैट दिस इज फॉर एग्जांपल फॉर द पर्पस ऑफ दिस कैलिब्रेशन बेसिकली। सो एनपीएल फ्लैटनेस इंटरफेरोमीटर, it comprises a simple optical system which provides a sharp image of the fringes so that it is convenient for the user to view them. Light from a mercury vapor lamp is condensed and passed through a green filter, resulting in a green monochromatic light source. The light will now pass through a pinhole, giving an intense point source of monochromatic light. The pinhole is positioned such that it is in the focal plane of collimating lens. Therefore, collimating lens object a parallel beam of light onto face of the gauge to be tested via an optical flat. So look at this particular one. ये सोर्स है आपके पास, ये कंडेंसिंग लेंस है, यहाँ ये पिन होल है, ये ग्रीन फिल्टर है फॉर एग्जांपल, देन इज द ग्लास प्लेट रिफ्लेक्टर है, ये आईपीस है आपका, ये ऑप्टिकल फ्लैट आपने यूज किया है, दिस इज कॉलिमेटिंग लेंस जिसमें कि पैरेलल लाइंस ये बनती है, एंड दिस फॉर एग्जांपल द बेस और वर्क विद दैट वी वांट टू मेजर। तो ये इस तरह से जैसे या तो मैन्युअली कर लो या तो you can make use of this kind of say interferometer which is given by this NPL, developed by this NPL. Okay. The results in the forming of interference fringes. The light beam which carries an image of the fringes is reflected back and directed by a 90-degree using glass plate reflector. The entire optical system is enclosed in a metal or the fiberglass body. It is provided with the adjustment to vary the angle of optical flat, which is mounted on the adjustable tripod. In addition, the base plate is designed to be rotated so that the fringes can be oriented to the best advantage. तो आप इसमें adjustment कर सकते हो so that you can orient the fringes according to the requirement जैसे आपको measure करना है. तो look at this particular one. इस तरह से पैटर्न बनेगा आपका, ठीक है? Example of fringe pattern. Equal fringes on the parallel surface. या equal fringes होंगे या unequal है. तो ये flat हो गया, ये flat नहीं है क्योंकि unequal आ गया इसमें. The figure illustrates the fringe pattern that typically observed on the gauge surface as well as the base plate. In figure A, the fringes are parallel and equal in number on the two surfaces. Obviously, the two surfaces are parallel, which means that the gauge surface is perfectly flat. On the other hand, figure B, the number of fringes is unequal, and since the base plate surface is ensured to be perfectly flat, the workpiece surface has flatness error. तो यहाँ आपको दिख रहा है flatness error. Due to the flatness error, the optical flat makes unequal angle with the workpiece and the base plate, resulting in an unequal number of fringes. Most of the time, fringes will not be parallel lines, but will curve out particular fashion depending upon the extent of wear and tear of the upper surface of the workpiece. जैसे हमने पहले देखा था pattern, different pattern. कॉन्वेक्स है, कॉन्केव है, वो मतलब वन साइड है, एक कॉर्नर पे है. Accordingly, there is for example, this fringe pattern. In such cases, the fringe pattern gives the clue about the nature and the direction of the wear. Measuring error in the parallelism for gauges longer than 25 mm fringe pattern on the base plate is difficult to observe. Therefore, the gauge is placed on a rotary table. तो ये एक इसमें नहीं होगा. अगर लार्ज सरफेस है तो उस पर्टिकुलर केस में आपको रोटेट करना पड़ेगा. ठीक है, चलिए आज के लिए इतना ही, बाकी कल देखते हैं फिर. Okay, so अभी I will mark your attendance. कल कितने बजे? 10 बजे सुबह. आपकी किसी की आवाज नहीं आ रही, पता नहीं क्यों.
Yes, sir.
You can just put your message in the chat box. Tomorrow 10 o'clock. Confirm it. So some people are typing their roll number right now. I asked them to type at the joining. So that's when they are joined right now. Okay. तो इसमें फिर उनको दिक्कत होगी अटेंडेंस में. ये अभिनव गौतम के बाद अभिनव गौतम, सत्यम परिदा, प्रियांशु, सुशांत. That means the people have joined the class right now. So that is not acceptable. एक तो पता नहीं आपकी आवाज नहीं आ रही किसी की. How can I take the attendance then?
सर आपको आवाज आ रही है?
I don't know, there is some technical glitch. मेरी आवाज आ रही है ना?
हाँ जी
Just
सर,
type
आपकी आवाज
yes
तो
in
आ
the
रही है.
chat box if I'm audible. Am I audible? Type
Yes,
yes
sir.
in the chat box. ये आप
Yes,
लोगों की
sir.
आवाज नहीं आ रही है मुझे. None of you are audible to me. अगर आप बात भी कर रहे हो तो मुझे नहीं पता. अरे हाँ ना कुछ तो बोलो, टाइप तो करो. मेरी आवाज आ रही है आपको?
Yes, sir.
Sir, we are typing.
टाइप करो टाइप. ये आपकी आवाज नहीं आ रही मुझे, पता नहीं क्यों.
सर टाइप तो कर रहे हैं.
So anyway, I'm going. There are 56 students who are present over here. I'm going to mark the attendance as per the roll number which is posted and written as a present in the chat box. ठीक है? आप लोग जा सकते हैं, मैं इसके हिसाब से कर दूंगा. As per the chat box, I will mark your attendance. You can leave now, no problem.
हेलो हेलो हेलो. सर मीटिंग एक बार रीजॉइन करके देखो.
सर नई क्लास अरेंज करवाओ. हेलो हेलो.